Okay, we're back. This is Techmath2. We're looking at review, chapter 13, 14. This is part 2. So we are on number 12. I'm only working out the problems off of the review that are going to be like on the test. So there is one just like number 12 on the test. All right. So let's take a look. Solve for R. So if we're going to solve this for R, we'd write it log base E d over R is equal to negative kt. So that means that d over R is equal to e to the negative kt power. And now we're trying to solve for R, so if we cross multiply and solve, we get re to the negative kt equals d. And now, again, if you want, you can write a negative exponent, means it moves it to the bottom and then becomes positive when you move it. That's like the price of shipping, is to take it from there to the bottom. And so you ditch the negative when you put it in the right spot. And now cross multiply and solve again. So we kind of cross multiplied and solved twice. I guess I could have did 1 over and just did it in one shot if I would have moved it down there. I just didn't think to do that. So now we cross multiply and solve, and we get R is equal to D times E to the KT. And that's it. If you would have divided both sides and left a negative KT there, I would still give you full credit. If you said D over e to the negative kt, like right here, instead of moving it up. You really should move it up, but unless they specifically say no negative exponents, you're still in the clear. So mathematically, they are the same thing. So I would still give you full credit if you left it that way. All right, let's take a look at number 13. Number 13 is solve for t when v is equal to ve to the negative t over rc. What a weird problem. So let's divide both sides by capital V, I guess. We have v over v is equal to e to the negative t RC. Let's write it as a log. So log base E of that, V over V, is equal to negative T over RC. And then let's multiply both sides by, like cross multiply, but we'll put the negative on the RC. So we have negative RC ln of v over v is equal to t. And that's fine. You can leave it like that. If you want, now you might be like, hey, that doesn't match. That doesn't match the key. Well, the key, what they did was they took this -1 and they pulled it up, just like how you can pull it down when there's a natural log, you can pull it up. And so they did this to the -1 power, and then a -1 on that does the reciprocal. So they have this listed as their answer. Capital V over small v is equal to t, like that. But guess what? Either one is fine. You can leave the negative there and give me that answer, or if you want to be fancy, you can give me that answer. Either one. So that's a tough problem. 15. All right, let's look at, there is one just like number 14. So let's do that one. We got, what is the slope of the line through these 2 points? So wow, this takes you back to your algebra days. Usually you cover that in an Algebra 1 course. And we do that a lot in statistics, like fitting a line. But we're just gonna find the slope of the line. So just the slope of the line. So the slope is the change in y over the change in x. You might remember that as rise over run. And now this little sub 2 minus sub 1 and sub 2 minus sub 1, that doesn't mean anything mathematical. That means that I wanted to use x multiple times, so I call it x sub 2 minus x sub 1, instead of using two different variables, instead of saying like x minus z or something. All right? So here's how we label these. Here's x1, y1. Here's x sub 2, y sub 2. And all you do is you take that thing, negative 2, minus that thing, negative 4, over x sub 2, 5, minus x sub 1, negative 3. Now, you got to remember your rules of algebra. Two negatives in a row make a positive. And a positive. And then negative 2 and positive 4 is positive 2. And 5 and 3 is 8. And now you have to remember to reduce to 1/4. Although, truth be told, if you told me 0.25, I'd still give you full credit. And you could get 0.25 by taking 2 divided by 8. So normally with slope, you write it as a reduced fraction 1/4. But I would still give you full credit for 0.25. All right? Okay, let's look at 15. There is one like 15a. So there isn't like B or C, but 15a. Write the equation in slope-intercept form. So what slope-intercept form really means, it's just a fancy way of saying solve for y. So say, put in slope-intercept form, they're saying solve for y. Is what that translates. So we want to solve this for y. So we subtract 3 from both sides. Now remember, you can't take 6x minus 3. Those are unlike terms, so you just leave it, 6x minus 3. And then you divide everything by negative 2. And so 6x divided by negative 2 is negative 3x. A negative divided by negative is a plus. You can make that 1.5 if you want. Yeah, I made it 1.5. That's fine. Equals y. And so now we have it. Slope-intercept form is solving for y. So y equals negative 3x plus 1.5. The reason they call that slope-intercept form is because the thing in front of the x is the slope, and that's the y-intercept. Slope-intercept form. All right? If you left it 3 halves, that's fine. If you said y equals negative 3x plus 3 halves, we're good. All right, let's jump down to 16. Write the equation on the line that passes through 4, 1 and is parallel to that line in slope-intercept form. Wow, so 16 is one of the hardest problems on the test. Again, we're kind of going back to, in algebra, you usually are working with these linear equations like this. And so they want you to know a lot of stuff. Parallel lines have the same slope. You have to know that. So let's take a look at 16. Let's pick this one apart. We have, first, let's write that as y equals, okay? So let's solve this for y. So negative 3x, 2y is equal to negative 3x plus 7, and then divide everything by 2. So y is equal to negative 3 halves x plus 3.5. All right? So why did we do that? They didn't tell us to do that. We have to do that because we need the slope of the line. So the slope of this line is m. That stands for monter, to climb the slope. Frenchman, René Descartes is the guy who figured out linear equations. So that's why m is always slope. So the slope is negative 3 halves. No x on it, just negative 3 halves. All right? That is the slope of the line. Parallel slopes are always the same. So it's just negative 3 halves. So this is the slope that we want. We want that slope, and we want it to go through this point. So we have a point, and we have a slope. Now, mathematicians have this thing called point-slope form. It looks like this. And what you do is you take your slope, we're going to put that right there for m. And then you take this x sub 1 and y sub 1 and you put it in here and here. So y minus 1 equals negative 3/2 times x minus 4. Okay? And now you have to solve it for y. That's why I said this is one of the hardest problems on the test. Yeah, there's a lot of hoops to jump through here. We have to first solve it for y so we can find the slope. We have to know that parallel slopes are the same, so we stuff that into this equation. And then you have to take those and put it in the equation. And now we have to solve this equation for y. So we distribute negative 3/2. Remember how we multiply fractions. Numerator times numerator, denominator times denominator. So plus 12/2, right? 3 times 4 is 12, and negative times a negative is a positive, and 2 times 1 is 2. And so, and that just stays negative 3/2. And now we reduce it to 6 and add 1 to both sides. So y is equal to negative 3/2 x plus 7. That is not an easy problem to do. So be ready for that one. There is not one like 17, parallel, perpendicular, neither. Perpendicular means opposite reciprocals. So A is neither, that isn't an opposite reciprocal. B, those would be perpendicular, opposite reciprocals, negative 3 and positive 1/3. And C, that would be parallel because it's negative 2x and y equals negative 2x plus 7, same slope, parallel. All right, but there isn't one like 17 on there, so you don't have to worry about that. That's just a nice little review of parallel, perpendicular, and neither. There is one like 18. What is the distance? So distance formula is just, again, formula manipulation. So make sure you have that distance formula handy. Okay, I think I have it on the review sheet that I worked out. Distance is equal to the x's being subtracted, and then the quantity squared plus the y's being subtracted, quantity squared, and then you take the square root. So for this, it is x sub 1, y sub 1, x sub 2, y sub 2. So negative 3 minus negative 1 squared plus 2 minus 5 squared. Now, I've had students freak out and go, oh no, what if I did that one as 1 and 2, or 1 and 1 and 2 and 2? Then I get it wrong. No, you wouldn't, because let me show you. Negative 3 plus 1 squared, that's negative 2 squared. All right? This is negative 3 squared. This is 3 squared. All right, that's all still under the square root sign. 4 plus 9, right? Square root of 13. And let's see, they want it to, 3 significant digits. There's a blast from the past. Let's see here, we got 3.605551275. So right now, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 significant digits. They only want 3. Remember how that works is just 3 numbers, or if there's a 0 included, then it counts as significant. If it's on the end, it doesn't count. But this one, we would round up. So 3.61. 3 significant digits. Wow, that's all the way back to Techmath 1. We did sig digs. Okay. So what if you would have switched those around? It wouldn't matter. This would have just been positive 3. And when it's squared, it would still be 9. And this would have just been positive 2. And when it was squared, it'd still be 4. So it really doesn't matter which one is first or second when you're subtracting the x's and subtracting the y's. All right? So then there is not one like 19. There is not one like 20. There's not one like 21. There's not one like 22. Again, they have those if you graph those and you wanted to check your work, that's in the key that I posted on the blank. But there is one. Is there one like 23? Nope, there's not one like 23 either, so there isn't, I have an X on that one. That's not on the test. There is one, though, like 25, A, B, and C, and there is one like 26, where you have to find the mean. So let's do that. Mean, median, and mode. So let's do 23, and then A, B, and C, and then 26. So no actual standard deviation on the test. It's just a little tedious. I just want you to understand what a standard deviation is you know, how far each thing deviates from the mean. All right, so let's look at 25. We got 15, 23, 36, 23, 27, 31, 35, 23, 35, and 30. So we want to put those in order from lowest to highest. 15, 23, 23, 23, 27, 30, 31, 35, 35, 36. All right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So n is equal to 10. And we got all of them. Lovely. So let's find the mean. The mean is you add them all together and divide by how many there are. So that's 57 divided by, or no, I'm sorry, 278. 278. When you add them all up, you get 278, and then divided by 10. So 27.8 is the mean. Mean is like average. That's what everybody knows as average. All of these are actually averages. Average is anything that describes the data, measures of central tendency. Median, you put it in order and you find the middle one, like the median strip in the middle of the street. So look, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pieces of data. So the exact middle is right here. So between 5 and 6 is going to be the median. So 27 plus 30, you hit enter, and then divide by 2. So that is 57 divided by 2, which is 28.5. And then the mode is the one that occurs most often. So the most repeated, there's 2 35s. Nope, there's 3 23s. So that one occurs most, so the mode is just 23. All right. If there would have been another 35, if this would have been 35, 35, 35, then we would have put 23, comma 35. Then it's bimodal. Both of them count as the mode. But if there's one that occurs most often, that's the one you take. If it's a tie for first place, then you put them both down. All right. And then there is one like 26 on the test, where it says a sample of cars sold in a week are 5, 2, 1, 3, 0, and 2. What's the mean? So that's pretty easy, right? I hope that's pretty easy. 5 plus 2 plus 1 plus 3 plus 0 plus 2 divided by 1, 2, 3, 4, 5, 6. So we're looking at 13/6, which is 2.16, which is 2.2. Is the average. So just, 2.2, a lot of people go, well, you can't sell 2.2 cars, and no, you can't, but you get that it's an average. So average isn't going to contain one of the numbers in the set necessarily. All right, so that is what the test is going to look like. This is not an easy test. Make sure to study and prepare. Review for chapter 13, 14 test.